Okay. 7.4 permutations. A permutation is a selection without replacement. That's the basic definition of what it is. So example 1 talks about 7 horses running a race. You only have 3 winners. Win, place, and show are the names of the 3 places. So there are 7 horses which can win the first spot. 6, once the first horse is won, there's only 6 choices for the second spot, and 5 for the last spot. Okay, this is the idea of filling slots, not playing slots. That's a different story, but filling them. So 7 times 6 times 5 makes 210 possible different combinations of horses coming in for second and third, or win, place, and show. Now, the definition for permutation. First of all, you're going to see this notation, which has a small subscript on the left side, a capital P, and a small subscript on the right side. N stands for the number of objects to choose from. So in the example of the horses, we would have had 7 here. R, the little subscript on the other side, represents the number of slots to fill. That would have been 3 in our last example. And the mathematical definition of NPR is n factorial over n minus r factorial. So let's take a look at what would happen with our horse racing example. So we have 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. All over 7 minus 3, well, that's 4 factorial, so that's 4 times 3 times 2 times 1. Anything cancel out? Well, certainly. All we're left with is 7 times 6 times 5. So that's the mathematical definition of permutations. Sometimes it's easier to think in terms of filling slots, and sometimes it's easier just to use the calculator. The calculator can do that work. You can type 7, hit the math button, PRB, NPR, 3, and it will calculate 210 for you. Okay, example 2. How many different 5-letter words can be formed from the word birthday? Well, we have 8 different letters and 5 slots to fill. 8 letters and 5 slots to fill. 8 times 7 times 6 times 5 times 4. Right, because this is 8 factorial. I should write it out this way. 8 factorial over 8 minus 5 factorial, which is 8 factorial over 3 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Boom. So we really have 8 times 7 times 6 times 5 times 4. Okay, well, we know that 7, 6, and 5 make 210. We need times 32. Oops, 210 times 32. 4 times 8 is 32. So 6720. 6720. Let me make sure I'm right on that. 8 math PRB NPR 3. Sorry, I typed the wrong thing. Math 8 math NPR 5. Yeah, 6720. I'm correct. Okay, something that you need to know and understand is a definition. Definitions are indisputable and cannot be proven. Don't try to argue with me. I know you will. 0 factorial equals 1. Believe it, own it, be it. But don't argue with it. Basically, our definition of NPR falls apart if that's not a true statement. So it better be a true statement, so we'll just make it that way. Mathematicians get away with a lot of murder in that case, you know. I mean, not real murder, but you know, it just seems like it. 5 permutations choosing with 5 slots to fill. So 5 objects and 5 slots to fill. That would be 5 slots to fill, 5 times 4 times 3 times 2 times 1. Oh, look, 5 factorial. But by definition, this is 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial. And if this thing down here does not equal 1, then these two things, which we know are the same, don't equal each other. That's a problem. So to take care of the problem, we just said 0 factorial equals 1, and then that's the end of the story. I know, doesn't seem fair. We can do what we want. Okay, in a situation like this, we're trying to find the number of objects that would make this particular equation true. So we can write out our definitions. We got 7 times n factorial over n minus 4 factorial equals n factorial over n minus 5 factorial. Obviously, we would like to get all the n's on the same side, so we're going to multiply by the reciprocal to get all the n's on the same side. And watch the magic happen as many things cancel out. Now, we have n minus 4 factorial, which is n minus 4 times n minus 5 times n minus 6 times n minus 7, dot, dot, dot. And on the bottom, we have n minus 5 times n minus 6 times n minus 7, dot, dot, dot. And that's equal to 7. Well, notice what all the things that cancel out. Leaving me n minus 4 equals 7. And if n minus 4 equals 7, then n equals 11. That was a lot easier than I thought it was going to be. At least it was a lot easier than you thought it was going to be. Okay, let's take a look at another example like that. So I got n factorial over n minus 4 factorial, and I got 90 times that, and I got n factorial over n minus 6 factorial. And I multiply by the factorials on both sides, obviously, right? Because I want to get all my n's on the same side. And a lot of junk's going to cancel out, right? And on this side I have n minus 4 and n minus 5 and n minus 6 and n minus 7. Blah, blah, blah. And in the denominator I have n minus 6 and n minus 7. Blah, blah, blah. And that equals 90. And we take a look at all the things that are going to cancel out. Anything from n minus 6 on down. Now that leaves me with n minus 4 times n minus 5 equals 90. Now, I want to come over here and look at that. N minus 4 times n minus 5 equals 90. If you think that you should FOIL that out, then you're going to have to FOIL it, subtract 90, then refactor it or use a quadratic formula. Personally, I don't think that's necessary, but that is possible. We could go through that painstaking process. Most of the time when I give a problem like this to kids, that's the first thing they do. Well, we should FOIL that thing. Okay? Let's take a look at it a little bit closer. I need to know the relationship between these two. N minus 4 and n minus 5. The relationship is they are consecutive integers. Remember, factorials are built on consecutive integers. So n minus 4 and n minus 5 are consecutive integers. This is telling me that the product of those consecutive integers is 90. Can you think of two numbers? This is like Dora the Explorer. Can you think of two numbers whose multiplication is 90? That's right. There's a big long pause and we wait. And maybe we'll find a map and see if that'll help us. Or maybe Boots can. I don't know. As long as Swiper's not in the picture, we'll be okay. So let's see here. And the product of 9 and 10 would equal n minus 4 and n minus 5. Those are consecutive integers whose product is 90. Okay, so let's see here. Which one of these is bigger? Is it n minus 4 or n minus 5? Well, think about that. Let's suppose n was 17. I'm not saying it's 17, I'm just guessing. If n is 17, 17 minus 4 is 13. 17 minus 5 is 12. So obviously, this one is the bigger of the two. So n minus 4 has to equal 10, and n minus 5 has to equal 9. If you solve both of these, you find the correct answer. Let's just say, for argument's sake, you accidentally switched them. And you said that n minus 4, which we know is the bigger one, but you picked 9, and n minus 5 is 10. You would get 13 and 15. What's the average of 13 and 15? Oh yeah, that's the correct answer, 14. So even if I mess this up, I will still get two numbers that are 1 unit away from the correct answer in either direction. Hopefully you'll set it up correctly and you'll be able to tell that the answer is 14. But if you didn't, the average of those two is the correct answer. Have a good evening.